A quadratic inequality is an inequality that is of the form ax squared plus bx plus c is greater than, or equal to, less than or equal to 0. Or rather an inequality that can be put in this form. Now, b and c, either of those could be 0, and so most notably we identify these as having x squared as the highest power. For example, let's take a look at the inequality x squared minus 4 is greater than 0. We recognize this as a quadratic inequality because the highest power is x squared. We're going to solve this graphically. So remember that when we solve graphically, we want to graph the left-hand side, set y equal to the left-hand side, and graph the right-hand side, y equals the right-hand side, and then look for the portion of the graph, of one graph that is above, in this case, the other graph. So let's write out this inequality over here where we have a little bit more space. I'm going to look at the graph of y equals x squared minus 4. Knowing that that's just a parabola shifted down 4 units, I can draw that very quickly over here with its vertex at 0, -4, and then using the 1, 2, 3, 1, 4, 9 pattern to fill in the other points. So from the vertex I'll go over 3 and up 9, over 3 and up 9, and get a nice parabola. So this is y equals x squared minus 4. We also know that y equals 0 is the same as the x-axis. So the line y equals 0, I'll go ahead and put here in red so that it'll show up. Okay, now looking at this inequality, a greater than we interpret as the word above, because we're talking about y values being greater. And y runs in the up and down direction. So I will highlight the part of this graph for which that applies. The part of the parabola that's above the x-axis is this piece here and this piece here. So if I want to translate that into a set of x values, well, it looks like along the x-axis, that's going to be from 2 to the right and from -2 to the left. I'm drawing these with open circles because of the strict inequality. Now looking at this graph and looking at the part of the x-axis that I marked up, I can go ahead and translate that into interval notation for my solution set. The first interval starts at -infinity and goes up to -2, ending in an open bracket, then a union symbol. The second interval starts at +2 and goes up to +infinity. What we're going to do next is use this graph to help us establish a procedure for solving quadratic inequalities without drawing a graph. So let's note that I could have used this information, a number line, instead of a graph. The two zeros are at -2 and +2, so these are the zeros of the function. And I can see that on the left of -2, the graph is above the x-axis, which is like saying it has positive y values. Between negative and +2, the graph is below the x-axis, which is like saying it has negative y values. And to the right of 2, the graph is again above the x-axis, which is like saying that it has positive y values. Now to interpret this number line, instead of thinking about the word above, what I want to think about is the whole expression, not just the greater than, but the fact that it says greater than 0. Well, numbers that are greater than 0 are positive. And that tells us that the intervals we want in our solution set are the ones with pluses. So that's going to be this interval and this interval with the arrows as they do continue off to the left and right. Now I can see from this number line, I also can get to this same solution set in interval notation. So even the process of solving a quadratic inequality symbolically still involves a number line. There's no strictly symbolic process that the answer will just fall out of, right? We can't just use like the zero product property with an inequality symbol in place of an equals. That doesn't work. We really have to map out the parabola, figure out where it's positive and negative, and then look back at our inequality and figure out which of those intervals belong in our solution set. So we're going to start from here to go on to a process for solving symbolically. To solve a quadratic inequality symbolically, we first solve the related equation. Now note with the language here, right? Equation means we have equals, not a less than or equal to, not a greater than, right? Nothing, no inequality symbol at all. So we're going to use whatever is the appropriate equation solving technique just to find those real zeros, because those are the numbers we want to mark on a number line. Then we plot those real zeros on a number line, very important. We have to use a number line in this process to divide the number line into intervals. Then we test each interval to determine whether or not that interval is part of the solution. So we'll look at that part when we have our number line marked up. So that means our first step is to, well, I'll go ahead and get this in the form of an inequality with 0 on one side first. Then I'm going to change it to an equation. Which means I'm changing my inequality symbol to an equals. This is just so that I can find the zeros and mark them on a number line. I can use whatever method for solving quadratic equations seems appropriate. Here I would factor because this starts with x squared and it looks like an easy factoring problem. But not every one of these is going to be possible to factor. So I'm going to say 5 and 1, and looks like -5 and +1 should get me the correct middle term. So that gives me two zeros, which are x equals 5 and x equals -1. All I need to do with my number line part is mark these on the number line in the correct order. Scale is not important here, and I would not recommend even putting 0 for reference. Any other numbers marked on here are going to be a distraction. So I have my number line marked up. Now what I want to do is identify the form of the inequality that I'm going to work with. So that would be this form right here where we have 0 on one side, and I need to make sure that I look back at that form of the inequality for everything from this point forward. The parabola opens up because it starts with a positive leading coefficient. The reason I need to be consistent about what form of the inequality I look at is if I had moved some terms around, I might in some of those forms have a parabola that opens up and in other forms have a parabola that opens down. So I just need to make sure I pick one form to look at for everything involving the number line. This parabola opens up. If I were to just very lightly dash in what that would have to look like on this number line, imagining the number line is the x-axis, it would look like this. It's a smile, right? So that tells me that my sign pattern goes plus, minus, plus. We are above, then below, then above. The plus, minus, plus is all I need to finish up, because the other piece of information that I'm going to take from this inequality is this less than or equal to 0. I have to ask myself now, numbers that are less than or equal to 0, are those numbers positive or negative? In my last example, they were positive because we had greater than 0. Numbers that are less than or equal to 0 are negative. This tells me that I want the negative interval in my solution set. So I'm going to select this one here and then think about the bracket type. This is an inclusive inequality, so I do want to include both of those endpoints using these closed brackets. So in interval notation, that solution set is going to go from -1 to +5. Following this same process now with another inequality, I'm going to start by getting all the terms on one side. That's going to look like this. -x² plus 7 is less than 0. This is the form of the inequality I'm going to choose to use when I get to the number line part of this problem. But first I need to find out what those zeros are, and to do that I'm going to change that inequality temporarily into an equal sign. In this problem I can see that the square root method is by far the easiest way to find those zeros, and I'm going to choose to add the x² term to both sides so that it'll be positive over on the right. This will just make the problem go a little quicker. Take the plus or minus square root of that 7, and then taking the square root of x² gets me just x. I can see that the numbers to mark on my number line are just minus the square root of 7 and plus the square root of 7. Keep in mind not to use decimal approximations here unless there's something in a problem that suggests that decimal approximations are what are wanted. Stick with the exact values. Exact means we're going to simplify these. If there were a perfect square factor that we could pull out, then we would, but in this case there is not, so we're just going to leave these as plus or minus the square root of 7. Now we come back to the inequality and think about how to mark up the number line. This parabola opens down, which we can see from the fact that it has a negative leading coefficient. Because it opens down, the sign pattern has to be minus, plus, minus. If I wanted to dash in what that parabola would have to look like, imagining this number line is the x-axis, this is what would happen. It crosses right at those two zeros, and it is above the x-axis, only in between the two values. Now I also look at the inequality in comparison to 0. This says less than 0, and numbers that are less than 0 are negative. So similar to the last example, we want to include the negative intervals in our solution set. That this time is the outer two intervals, the first and last. So finally putting that into interval notation, we get -infinity to negative square root of 7. Round brackets, open brackets here because of the strict inequality, positive square root of 7 to positive infinity. And let me reflect those bracket types onto the graph as well.